Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is arithmetic finance. What we are going to discuss today is present value of an annuity. So let's begin. After completing the very lesson today, my dear student will be able to explain the term present value of an annuity. Number two, also be able to calculate the present value of an annuity. These are the two things I hope my dear student will be able to do after completing the very lesson today. So as usual in your favorite segment of the lesson, that is Mercy's Fun. Today, my dear student, I'll give you another special group of numbers. This group of numbers are called the mystery numbers. I will explain what are mystery numbers with an examples after completing my lesson today, so don't go away. To begin this very lesson, my dear student, let me first explain the concept of this present value of an annuity. And to do that, let me just pose this very question to you, my dear student. Suppose I ask you to choose between receiving 10,000 naira right now or receiving the same 10,000 naira but in 5 years to come. I ask you this very question. Will you like to collect the 10,000 naira right now or the same 10,000 that I will give you, but I'll give you in the next 5 years to come? I'll know what to surely choose among these two. Surely you definitely choose to receive the 10,000 right now because you know that this 10,000 naira is worth more than the 10,000 naira in the 5 years to come. Because if this 10,000 is invested or saved in 5 years time, it will be something more than 10,000. So surely you definitely choose to collect the 10,000 naira today instead of collecting the same amount but in 5 years to come. So the present value of an annuity simply refers to the small amount today that will be equal to a large amount in the future. Is that what we call the present value of an annuity? Present value of an annuity, AP, is calculated by using this very formula. AP equals to R multiplied by the bracket. Inside the bracket, you have 1 minus another open bracket, 1 plus I, the small bracket raised to the power of minus n all over I. This is the formula we now used to find the small amount today that will be equivalent to the amount of our annuity in the future, where the R is the size of the regular payments of that very annuity. I is the interest rate and N is the number of payments. Example number 1, it says determine the present value of an annuity of this 20,000 naira that is invested at the end of each year for 5 years at 10% per annum compounded annually. So solution to this very problem. Remember in our previous lesson, we learned how to find the amount of an annuity. So if this were annuity of 20,000 invested each and every year for a period of 5 years, and that investment offer 10% compound interest, and the interest is calculated each and every year. So this amount will now be something big. So we have to find a small amount today that will be equal to the size of our annuity. So let's just move. So solution to this very problem, what we do first is to write down the formula for the present value of an annuity. AP equals to R multiplied by the bracket. Inside the bracket, you have 1 minus bracket open inside 1 plus I raised to the power of minus n all over I. This is the formula for finding present value of an annuity. So what we now do, we now find R, I, and N. So R is the size of the regular payment, which is in this case is 20,000. So this is 20,000 my R. Next is N. How many times this 20,000 will now be paid into that very account? It says paid at the end of each year for a period of 5 years. So it is now going to be paid 5 times. And next is I, that is the interest rate per time per period. This interest rate is 10% and is compounded annually. So you now have 10 over 100. And this 10 over 100 gives you 0.1. That is in decimal. So I now substitute my R, my N, and my I in this very formula to find the present value. So there, substituting, I now have R as 20,000 multiplied by the bracket open. Inside the bracket, you have 1 minus another bracket open 1 plus 0.1. This is your I. And that small bracket raised to the power of minus 5, that will now be your n. N is 5, so minus 5 all over I 0.1. So what I'm going to do next, this small bracket that I have inside this large bracket, I'm going to perform the addition inside there. That is 1 plus 0.1. That gives you 1.1. So next I'm going to do is to find the 1.1 raised to the power of minus 5. What will now be the value? So 1.1 raised to the power of minus 5, if done correctly, will now give you 0.62209. I continue. So what I'm going to do next is to subtract 0.6209 from 1. If that subtraction is done correctly, you now have 0.3791. So what I'm going to do next is to divide 0.379 by 0.1. If that division is done correctly, you have 3.791. And what I'm going to do finally is to multiply 3.791 by this 20,000. That gives answer 75,820. So this is the amount today that will be equals to amount of this very annuity. If I take it as an annuity and calculated the size or the amount of this annuity, it will be very larger than this. And this is what will now be equivalent. That is the amount today that will be equivalent to that annuity. Let me just remind you what is this. If I just draw a line here, try to find this very annuity of this very investment. That is investing 20,000 at the end of each year for a period of 5 years, and the interest rate is the 10% and is compounded annually. If you now substitute in this very formula, just our previous lesson, amount of an annuity, this is the formula. If you substitute, you discover that this very annuity will now have amount equals to 122,102 naira. This is the size of this very annuity. You can see this this 20,000 that is invested each year for a period of 5 years. It will now amount to this 122,000 naira 102. That is the total money paid or invested plus the interest accrued. This is the amount. And we now say that this very amount is now equal to 75,820 naira presently. So these two amounts are simply equal. This is the amount today and is equivalent to this large amount in 5 years to come. So let me just move and take another example. Example number 2 says compute the present value of an annuity of this 5,000 naira at the end of each 3 months for 2 years at 5%, and the interest is calculated or computed quarterly. So solution to this very problem, what we now do, write the formula present value of an annuity. AP equals to R multiplied by open bracket. Inside the bracket you have a fraction. Numerator of that fraction is 1 minus another open bracket 1 plus I, and that bracket small 1 raised to the power of minus n all over denominator of your fraction is I. So there we get our R, N, and I. Let me go on. So R is the size of the payment that will now be made each and every 3 months. So we now have 5,000 as R. And the number of payments, N, is what we find next. This 5,000 will now be paid each and every 3 months for a period of 2 years. So in just 1 year, there will be 4 payments. So in 2 years, there is now going to be 4 multiplied by 2, that is 8 payments. And the interest rate per annum per period is now I, which we now said is 5% per annum, but it's being compounded quarterly, meaning quarter of a year, that is 1 over 4. So we now have 1 over 4 times the interest rate per annum, 5%. So if this multiplication is done correctly and divided by the denominator, you now have 0.0125. This will now be your I in decimal. So we now substitute in this very formula. We now have the present value of this annuity will now be equals to 5,000 multiplied by open bracket. Inside the bracket, you now have 1 minus as denominator, another bracket open 1 plus 0.0125. This will now be your I. And that small bracket raised to the power of minus 8. So 8 is your N all over 0.0125. This is your I. So I continue. So what I'm going to do is the addition inside the decimal bracket. 1 plus 0.0125. That gives 1.0125, and that value raised to the power of minus 8. So what I'm going to do next is to find the 1.0125 raised to the power of minus 8. If that is done correctly, you now have 0.9054. So what I'm going to do next is to subtract 0.9054 from this one. If that is done correctly, you now have 0.0946. So next I'm going to do is to divide 0.0946 by 0.0125. If that division is done correctly, you now have 7.568. And now multiply finally 5,000 by 7.568. If that multiplication is done correctly, you now have 37,840 naira. With this, I have come to the end of this very lesson, my dear student. I hope you find it resourceable. And let me just move quickly to the last segment, Maths is Fun, and explain what are mystery numbers. A number is mystery if what happens if that very number can be expressed as the sum of two numbers, and those two numbers should always be reverse of each other. Let's take examples of mystery number. 120 is a mystery number. If it were a mystery number, it means I can express this number as a sum of two numbers, and those two numbers are reverse of each other. Let's see how we can express this 121 as a sum of two numbers which are reverse of each other. 121 is the same thing as 92 plus the 29. 92 and 29, you can see they are reverse of each other. If I add 92 and 29, the result will give me back this 121. So 121 is a mystery number. Let me just give you other examples of mystery numbers. You have 33 is a mystery, 44 is a mystery, 55 is another mystery numbers, and many more mystery numbers. Thank you for your attention. We see more of those things in mathematics in our subsequent lessons.